I will go deep into machine learning, but not something theoretical. I will show you how to write a SQL in order to resolve the machine learning problem. I have brought to you two examples. Hopefully I will have enough time to do it and show you this stuff. BigQuery is a Google platform product. So we will talk about GCP from now on, from here. And for the BigQuery, it's analytics as a service, which means that you don't need sysadmins. It's like an API. You only just feed in the data and you actually consume the data. It's also called a federated data source in the cloud, actually in the Google Cloud, because Google engineered all the 400 services which they have in the cloud to actually federate, like connect all the data feeds into BigQuery, and you have a central way to actually query everything. Just an example, Google Analytics, for those who actually develop websites, for example, you can actually export the raw Google Analytics data in BigQuery as a table, as you know, as a SQL table, and you can join that with your own data set, which you also imported in BigQuery. And this is something wow for me, because I can address from Google Analytics a lot of metrics which I can actually relay link to the users. It's the most, let's say, hidden gem in the cloud. So Amazon and Microsoft is trying to copy this product. I hope that they will eventually copy it, because that way Google will have actually a market actually to actually lower more the prices and so on, even if the prices are SD. Even if the prices are low, like storing is only 20 for a terabyte, and querying is only 5 for a terabyte. So often when I'm actually asked what's the biggest table I worked on, I don't say a couple of gigabytes, I say terabytes, even petabytes. I didn't live living and querying the petabyte still, but a couple of hundreds of terabytes, yes. It has the SQL 2011 standard with the JavaScript UDF. And I mentioned that JavaScript UDF. So yes, I'm able to write user-defined functions, or the functions which we were taught in the university in JavaScript language. And I can actually inline all the JavaScript libraries from the internet, like the natural language processing library, inline in the SQL. And if I have a text in a column, I can both link to it. So this is about my experience about BigQuery. You should try it out. It's an awesome product to actually play with. You only need the browser and the credit card, because it's in the cloud. You need to have a credit card in order to pay what you use it. They have a free plan up to 1 terabyte, so you can still play plenty of fun. And BigQuery ML. So this is actually an extension to the BigQuery ML, and this is actually very new. It's like last year's product. They extended adding the SQL language to actually query machine learning models. And it executes the initiative without moving out actually from the interface, from when you work with the data. It integrates also model, and it automatically does parameter tuning. So often when I'm talking about machine learning, I find it hard because it has a steep learning curve. But when I work with the managed service, then it's hidden some information for me, and they automatically choose the parameters for me. Why? Because big vendors can run like 20 times your algorithm with different hyperparameters, and they can pick the best for you and return for you that, and it's some point hidden for you. Of course, you can tune everything, but as a first starter, it's extremely great to do that. As the internet, open source, and either enterprise and other cloud has different products, like TensorFlow, CloudML, also AutoML, and the API and API engine is a different thing. I want to show you that BigQuery is actually for the SQL analyst. Often in this city we don't have these exact roles. We have developers, But I just want to showcase you that, for example, AutoML, here you only need just the browser and some zip file. For the BigQuery, you need to write SQL as well. And for TensorFlow, you need to code at least a couple of days to actually get a working model for that, and you need to run somewhere that model as well. And let's see about ML. For those who don't know, ML is actually a bunch of enumeration and a bunch of lists. I just don't want to spend explaining all these things. Some of that I may need to further develop for myself as well, because one thing understanding how machine learning works, and the other is to actually come on the stage and explain in a kitchen language to understand it. But I will actually show you the two highlighted options. Those that, for example, the binary logistic regression is actually telling you something that it's a true or it's a false, it's a yes, it's a no, it's a dog or not a dog, or something like that. And for the matrix factorization is something like recommend me a value where I have a bunch of zeros, but I want to have values like in order to order my data set later. It's a recommendation factor for that. My favorite from this will be, because I don't have too much time, is that when I will be able to develop TensorFlow models, and actually just the model, to import the model, which is 200 megabytes at least, or at most, 200 megabytes at most, just the model to import in the SQL database. And for example, whoever wrote me a model, or there will be recipes, websites where we download the models, we can actually wire it into the data. Of course, so first example, because I don't want to go too much in theory, I just want to show you how this should work out if you first experience with that. So in this tutorial, I will have the Google Analytics dataset, which means that I have a bunch of hits from a website, or which pages the people visited, and so on. It doesn't matter at this point what kind of information. And I want to create a model that predicts whether a website visitor will take a transaction, will make a transaction. Often there are reasoning behind that, but this is just a small example. And this is how it works. So I need to write around 10 lines of code, and hopefully SQL is something that first you need to cover the big picture, and then you need to go a bit deep in the system. So we have I need to find something that works on the LCD better. So the select is a thing that actually you need to select the features. I can say that here the feature is actually the operating system, if it is mobile, country, and the page view count. This is actually my features here. And actually the training phase is giving data to the model, like where I know my labels. It's called label, it's the universal word for that. And where I have transactions, I name that label is the true and false state of my model here. And actually, if I have here like a couple of millions of entries, I can feed in all the data, and the model will be created by just issuing create model, the name, the option, what type of models BigQuery supports. I can add there in the model type parenthesize lots of other options. I can tune my parameters as well. And this is actually what's creating the model syntax. As you see here, it ran for 7 minutes, so it's not a select statement, it's create model statement, it's not like that, and it processed like 23 megabytes for this model. Okay, that's the first thing I need to do. Next thing is I want to evaluate how good is my model is. And I jump to the conclusion here that my precision is 46%, which is, for my simple example, is not great. Often people say that the machine learning is still great. In my experience, like 65, from 65, usually the managers can be convinced that machine learning is a good solution for something. In real life, you won't see 99%. But for example, if someone walks in a bank with a firearm and there is a silent alarm automatically issued by just using the cameras and taking note that there is a firearm, it may save some lives, let's say, so that even if that firearm is just a kid, something and not. But it's actually faster than a human seeing that, hey, this is a bank robbery or something like that. So that precision, for example, for that situation is extremely good. Now, what we have here on the screen is that I have a special source for my data, which is the ML evaluate, and it produces me this table. I don't go into this kind of explanation. I just to verify your model. If you add additional parameters, you change these options here. On the BigQuery UI, you have some graph charts for this as well, in order to actually see the iteration as you improve the model. And let's see now the results. And the third one which you need to know, and this is the third one, is the predict. And you are predicting something here. So I will jump to the conclusion here. So we have here the predicted labels and the probability numbers for my predicted labels. It's just a sample example to put on the screen. The big work is actually when you have a bunch of data and you actually need to validate that data that indeed this works or not. And you probably will find out in the first iteration that it doesn't. And you actually need to produce better results. And producing better results means that you need to further develop the model and actually choose other features as well. It's not a problem for choosing like 10,000 columns here. Usually around 200 we do, so it's big for choosing 200 columns. But in order to have a good machine learning model, you need to have something like that. Okay, and what we have here is that we have the predict, and I didn't mention that I used here a date range that wasn't seen before. So usually when you train your data, you need to train with an unseen, you need to evaluate and you need to predict on unseen data sets. And it's easy to actually train on different margins for that. That's it to actually get a model and actually get a prediction for that. You need to, so this was a generic example. If you want to go into individually seeing which people you want to recommend someone, you could add in into our list like the full visitor ID, which is actually the person's identification. And you can also sum and group by for that, and you come up that you have this table that you have a bunch of IDs where you have the total predicted purchases, and feeding this information in your business application can actually relay the business value for that, because you can market to these people for this. Okay, this tutorial is online as well. So if you Google up the previous enumeration, you can play with this example at home yourself as well. One more example, and this is much more easier to actually understand. This is matrix factorization. It's used for product recommendation. This is recommendation and not prediction. So the first was prediction, this is recommendation. And here you have the market target optimization tool, which we can use in everyday lives. And let's see an example. And let's focus here first. I will go on this. So in order to have this data working, we need three inputs. And we need the user, we need the item, we need the rating. These are definitely words. Often people ask me, what's the rating? So the rating is actually just a number which you actually come up with. For example, let's take a booking.com example. The rating actually can be has kitchen, has television, has AC, whatever. You come up with a formula for that and you compile it to the numbers. And this is actually the rating. And producing these three inputs, you produce a matrix. Now, in SQL, you cannot literally produce a matrix. That's a bunch of rows with 3 columns, but visualized it's like this. And you will observe that you have a bunch of zeros. And my task is actually, I want to sell coffee. And I need to find out who to sell coffee. Like, I have a bunch of zeros. I don't know who wants coffee. And I have a budget only for 1,000 people. So suppose that I have like a big telco company, like 10 million users, and they have a marketing budget for only 1,000 people. And they want to find out from those 9 million, who are the 1,000 people who actually good fit for our case. And this is, so our table produces the users with a bunch of zeros, and the model, when it's run, it produces numbers for the zeros, and then I can order the data because I can choose the first 1,000 and so on. So this is actually much more visually appealing, and I didn't mention it's working on tabular data, so you don't need any visual pictures, audio, something which machine learning usually does. And to run this, I will go just quickly. So I have here the 3 items which I need to select. Then I have the recommend this time, not the predict. And the recommend actually returns this in this form. It returns every user item there. So for 10 million, it actually can produce you a Descartes product. So it could actually produce you like a couple of terabytes of outputs. And the people run into the next time when they actually they want to give a person, for example, if it's a good fit. For that, as a testing purposes, because it's just too much to process. And then you can add here, select John as a second parameter, and you can combine with a query like, I want all those products where he didn't purchase anything. So I want the new products, like Emma.row could actually have this in their system, and they can eliminate all the users who actually were already purchased some things for it. That's actually the technical part. And the conclusions is that ML is, so mindset blockers first, because people still think that ML is something unreachable. So machine learning is hard. We don't have a dedicated team. That's true for our company as well, so it's not something that's hidden nowadays. With BigQuery ML, you don't need a team. You have only the SQL developers. And actually, the key part is here, understanding how to connect and fulfill a business requirement, because often that's actually what's broken nowadays. And often people don't realize that starting using the cloud is a complementary system, which means that I don't need to take my stack and put everything into the cloud. I can see like a service, just one single piece of it. I can feed data and the system works as it was, but I can feed data into the cloud and use the cloud as well. And increase innovation and work on fun stuff. So often developers come to actually to us that, hey, I'm still developing that boring stuff. I have a 10-year code base. I want something new. So when you want to add something in your team, you should actually use something from the cloud, because it's often easier for that. BigQuery ML, as Google defines, is that democratize the use of machine learning. You need only generalist team, increases innovation, and a model is easy to change and recycle. You may have heard that running the machine learning model on TensorFlow could take days, and you need to pay that GPU. In the end, you actually need to iterate those days, so you may need to run like a couple of months, and that's actually, it's an expense that you need to pay. And here on the BigQuery, it's actually easy to change and recycle. You don't harm any any living something. So the possibilities which we need to identify, Romania should identify the possibilities, because often nationalism is coming here. So we can personalize ads, email, web page content, which I know personally. For that, we can also predict customer value. Often we don't have infrastructure to serve the same customers with the same technology, like latency. We have like the top 20 to serve with a lower latency and lower backend. And also in the media and gaming, nowadays personalizing content becomes much more something of the future. And you can actually, you can find out if someone is interested in, I don't know, Game of Thrones character and marketize using that or something similar. You need to think around this. This concludes my talk. The slides are on SlideShare, Márton Kodok. It's a longer option there. It's much more evolved for that. And if I may, that I'm trying to run IT Mureș, and IT Mureș, in order to organize some meetups, we need speakers. So if there is a speaker next to you, or at the company someone is good, then you should try to find me and we can organize a meetup for you. And for the community as well.
This sounds great. Yeah, you can start with the two guys who just presented before. So.
Yeah, for sure.
And let me know if you need any support on this. Okay, so any questions?
Thank you for the presentation. So my question is on the other side of things. So right now you said you have some experience in using machine learning for customizing recommendations for people. And recently I've noticed this increase in such techniques. And it's starting to bother me because I'm creating my own bubble. So because I like some things, it's going to show me all those things over and over again. If I have a circle of friends, we're going to end up with the same things over and over again. Is there a strategy coming up against this? Or is there something that we can use in our products so we're not funneling people into a corner so they get some variety in their products?
Yeah, that's actually a good question. I had attended a talk around this thing, and the key takeaway from there was that we are living an era where I'm trying to find the good word. It's that the viral things and actually a new music hit from Madonna or whatever can actually burst into this old funnels and well. And the recommendation was that when you actually have your results on the product for the end user presented, like let's say 200, you can feed in 50 from an algorithm, 50 from a different concept, 50 recently which you actually don't have data already, and 50 randomly. And you can still use this technique as well. That Spotify does great on the recommendation list. Spotify runs this on Hadoop. You can find on YouTube like 2 hours of talks how they do that. And the trending, that's the word I wanted to find. The trending stuff is actually disrupting that what you actually require. But in order to have a sense to actually just see the local community's Facebook, for that, you need also influencers, because the trending stuff is something that they produce. So you need producers as well. And you actually often people in the market, in the online marketing, they are paying the influencers to disrupt things, because they know as well that everyone sees the television, they sees I don't know what markets, but they want new stuff and influencers come back here.
Very nice presentation, thanks. I want to ask you, are there any possibilities to running BigQuery in localized system or very secure? I mean, I'm thinking about very sensitive data that might not be comfortable sitting in the cloud, and I'm wondering is there any way in which you can run this locally, you can play with this or something?
Yeah, so the short version is that you cannot run locally. The too-long version is that I was in San Francisco at CloudNext a couple of weeks ago, and they presented big partners there. And by big partners, I can name the Chase Bank. And the Chase Bank, which is a very big bank in America, representative talked about how they moved to the cloud. And from that discussion, so it's not, I live the experience, so it's not my product. They mentioned that they are moving to the cloud because there is a customer encryption key, which I know but I didn't use. There is a customer encryption key when you set up for your data set, and that customer encryption key further encrypts your data in the cloud, and you have that only for that. Now, and they have a protocol on paper, because I don't know, on paper they have a protocol, and they give you a paper that the BigQuery system is PCI compliant and what kind of compliance in things. And often in an organization, when you come to the manager and you convince the product, hey, let's use this product, you have the legal base that, okay, we have the paper. In real world, if that works like that or not, I'm not taking any guarantees, and I think nobody takes, but often you have not the papers equilibrating things in order to actually run some products.
Okay, and I also wanted to ask you about the models. I mean, if BigQuery is creating models, can I use the models that have been created? I mean, can I download them? Can I use it in different systems other than?
It's not going back. There was that table with the BigQuery AutoML and Cloud Engine. I will swap. This one. So this one here. So I would say that you cannot customize AutoML, which is just uploading a zip file for a bunch of photos, but you can export the model at some point. It's a zip file as well, the TensorFlow model. On BigQuery, they don't offer, and I think won't offer at all exporting the model because it's a hidden gem. It's very cheap. Let's say that's cheap. For running that, and if you come at engine, it is API and engine different as well. You develop and deploy here, and as well TensorFlow is being deployed. So actually you are creating the model and not Google. Google is just offering you the infrastructure to run that thing. So that's how it works this. I won't see that BigQuery goes into opening this because you, for example, keeping 1 petabyte of data, you need like, I don't know, like 40 machines with 40,000 euros each, and that's cost. And storing in BigQuery is only $20,000 a petabyte of data, so it's not that big for a company to say so.
Thank you.
Okay. Yeah. Thank you, Márton. It was great.